Okay, waves, question 2. Figure 1 shows 4 waves. The waves are drawn to the same scale. Here they are. First question is, which wave has the greatest amplitude? And you have to tick one box, the greatest amplitude, tick one of these. Amplitude is amplitude is a measure of the displacement from the rest point. Okay, so imagine waves on the water. When the water's still, the water is at its rest point, and what happens as soon as there's a wave that passes through it, it will move up and down. So here's the rest point for each one. So we're looking for which one is the tallest wave. Well, we know straight away just by looking at it. That's the highest wave and also the deepest. So the highest crest, the deepest trough. Okay, these two, B and C, look about the same, and D would be the lowest amplitude. So wave A has the greatest amplitude. Which wave has the greatest frequency? Frequency is the number of waves in 1 second. So assuming these have all been drawn to the same scale, time scale as well, we're looking for the one with the most waves. Well, we can see there straight away that B has lots of waves. Each wave has one crest and one trough, or one peak and one trough. Peak and crest are interchangeable, mean the same thing. So here we have lots of waves. Whereas here we only have one wave, here we have 2 waves, and up here we have 2 waves as well. So that would be answer B, greatest frequency. Which wave has the greatest wavelength? I'm going to tick one box, greatest wavelength. That is the length of one wave. So we're looking for the wave that's the longest here. Well, this has got 2 waves in it, it's 2 peaks, lots of peaks. These are really short. Now see, that's going to be the longest there, is wave D. Okay, so hopefully that's a fairly straightforward question. Let's look at number D then. So we've got a wave has a frequency of 1,650 hertz, a wavelength of 0.200 meters. Calculate question, the wave speed. We've got to use the equation. So this equation we've got to use. Here we've got to calculate the wave speed. It's got a frequency of that, a wavelength of that. It's worth 2 marks. So the fact it's worth 2 marks suggests to me straight away that it's not going to be, there's no tricks in this. It's unlikely to be any conversions of values or anything else. So I go back to every. So the first thing I'm going to do is put the equation down. They've given me the equation here, but I'm going to rewrite it. V equals F lambda. Okay, I know that's V, that's F, and that's lambda. Don't worry if you can't remember the units, the symbols. You've got waves, any symbols will do for this really. I'm then going to write my values. The frequency is 1650 hertz. There's no milli, micro, mega, kilo in there to worry about, so I'll just leave it as it is. And my wavelength is 0.200 meters. Again, that's not in centimeters or millimeters, so I'm happy and believe that as it is. I then enter my values in over here. So 1650 times 0.200 equals, solve that question. So 1650 times 2 equals 330 meters per second. There's my wave speed. And that, interestingly, is a normal speed for the speed of sound. Okay, let's have a look at the next question here. So a student uses a mobile phone app that displays sound waves. Figure 2 shows the student holding a mobile phone close to the loudspeaker. Figure 3 shows the wave pattern seen on the phone screen. The displacement against time in seconds. What is the period? So what is the period of the wave? I've got to tick one box. The period is the time for one wave. Okay, so it's the total time for one wave. Remember, every wave has a peak and a trough. Okay, but only one. So the easiest way to do this is to start here. We're looking for the next point, so if I get to that point there, I'm looking for the next point that's identical to that one. And when I mean identical, it's got to be the same height, it's got to be on this axis here, on this displacement 0, it's got to be on there, but also the wave is the same, it's exactly the same shape before and after as well. So here, it can't be that one because the wave shape, this is going up here, whereas the line here is going down, that's no good, it would be over here. So that would be one wave in total. If this was measured in meters, that would be the wavelength, but it's not, it's measured in seconds, which means that that's the time for one entire wave, which we use the symbol capital T. So the time period here is 0.04 seconds. Okay, let's have a look at the last part of this question. So figure 3, so we're looking at figure 3 again, shows the wave pattern seen on the phone screen. What have we got to do here? We've got to determine the frequency of the wave, and we've got to use the physics equation sheet. Okay, so we've got to determine the frequency of this wave, so this is the number of waves in 1 second. It's worth 3 marks. It's a calculation question. So the first thing we do is we know the time period for this wave is 0.04. We just found that out a second ago, sorry, 0.04 seconds. And what we'd find on the equation sheet is this equation here. We would find frequency equals 1 divided by time period. Okay, so there's our equation. In fact, I've got a feeling we wouldn't find that, sorry. We'd either find that or we'd find it in this form here. I've got a feeling we'd find it in this form. So I don't have it handy, so can't check. But I think it says time period equals 1 divided by frequency. So I think actually we get that. So 1 divided by frequency. So there's my equation. Next is my values. The only value here I need to worry about is t, and that's 0.004 seconds. The great thing here is if you've written down on the previous number, if you wrote down the wrong time period, you put 0.08 because you just made a mistake, that's fine. The examiner will only penalise you once for that. Okay, so you can, whatever value you got previously, use the same value here. So I'm going to assume that the equation sheet doesn't give us that, it gives us this one here instead. So I need to find frequency, I've got the time period. I've put the values, I don't need to convert them, and I enter the values in here. So I get 0.004 equal to 1 divided by f. I then need to rearrange and solve. So I need to get both sides, I need to get rid of that divide by f first of all. So I'm going to times both sides by f, 0.004 f equals 1. And then divide both sides by 0.04 to make f the subject and leave it on its own there. So 1 divided by 0.004 equals, so 1 divided by 0.004 equals 250 hertz. Okay, right, hope that's useful. Take care.